It is necessary to identify which molecular gas pedals are used in the Monster Hadron Collider before moving on to the statement. The LHC, which CERN operates, is a 17-meter ring of superconducting magnets. Similarly, it is the most well-known and significant particle smasher in the world. It is the height of human scientific achievement. In fact, it is so powerful that it could replicate the actual states of the first interactions on Earth. However, could this device, which was meant to unlock the mystery of the universe, pave the way for something else entirely? CERN, which was established in one of the most well-known years, 1954, is one of the largest research organizations in the world, with 23 member nations and numerous researchers. Although the LHC is CERN's main project, it is only a piece in an enormous system of tests and gas pedals. Imagine a course that focuses more on subatomic particles than cars or people. In order to practice talent, diligence, and manipulate space itself, the LHC accelerates protons to almost the speed of light, putting them on a collision path that captures the energy of the universe at the moment of the Big Bang. The impacts produce temperatures that are typically hotter than the sun's center, and a vast number of magnets direct the protons on their journey, while intricate cooling systems maintain the magnets at temperatures lower than outer space. The LHC's pillars are designed to crash at 4 districts around the gas pedal ring, connecting with the 4 locations: molecule identifiers CMS, ALICE, and LHCb. Each fulfills a unique purpose by investigating extraordinary molecular material science fragments. Together, they function as beast cameras, recording images of these accidents, and experts sift through the debris in search of signs of the elusive Higgs boson, also known as the God particle, and other anomalies that provide fragments of the universe's fundamental building elements. They allow us to focus on the microcosm and learn more about it. But every response raises new questions, and every revelation leads to new tests. The LHC is more than just a logical tool, it is an expression of human curiosity and advancement. Regardless, as we push the limits of our knowledge, we should also take into account more existential and serious questions, such as: what are the risks of examining the unknown? Are we prepared to witness forces unexpectedly opened, over which we may have no control? In the holy halls of CERN, human understanding is constantly pushed. A revelation has emerged that chills even the most well-prepared research seekers. Former CERN scientist Brian Cox, an authority in the molecular field and recently a major figure in physical science, made a statement that has both fascinated and unnerved people worldwide. Cox's comments reiterate with gloomy clarity: the goal of CERN's Massive Hadron Collider is to replicate a small-scale Big Bang. Yes, you read correctly, a miniature recreation of the event that led to the formation of our universe. Physicists have also managed to make sense of the ramifications of this objective, highlighting the LHC's incredible ability to make new discoveries. This includes its ability to reveal the Higgs boson's privileged secrets and explore dark matter, an odd substance that constitutes a crucial component of the universe. Imagine being able to grasp the power of creation and the capacity to call forth the universe's actual embodiment. It is an alluring opportunity, but it is also fraught with danger. The scaled-down Big Bang is more than just a theoretical idea, it is a real fact that exists inside the LHC. The temperatures, tensions, and crude energy all replicate the conditions of the universe's birth. It's like being at the beginning of written history, witnessing the introduction of presence itself. Despite having such power, responsibility is essential, and the question arises: what if something goes wrong? In fact, back in 1978, the Russian physicist Anatoly Bugorsky encountered a catastrophe that would permanently alter the course of his life. While working on the U-70 synchrotron at the Institute for High-Energy Physics in Protvino, Russia, a failure caused his head to accidentally come into the direct path of a proton beam. The beam entered the back of his head and exited through his nose. Bugorsky had an incredible experience. He saw a flash that was 1,000 times brighter than the sun, yet he was stress-free. This episode isn't just a personal tragedy. It serves as a reminder of the terrifying power and potentially dangerous nature of these beams. The path of the beam left destruction in its wake, consuming bone and tissue. Yet, remarkably, Bugorsky remained conscious and even walked to the medical center for treatment. The outcome was both upsetting and captivating. The beam's path caused limited tissue harm, leading to hearing loss in one ear and partial facial paralysis. Surprisingly, Bugorsky's intellectual abilities remained intact, and he continued his scientific career. The potential for frightening consequences is one of the hazards of a particle smasher like the LHC, a danger that should not be underestimated. Altering the fundamental fabric of existence is a real concern, expressed by respected experts, not just the stuff of science fiction. One of the most disturbing and fascinating possibilities related to the LHC's experiments is the creation of a tiny black hole. Researchers and the general public alike find it astounding that the LHC could potentially create such a substance, even in trace amounts. Black holes are regions of spacetime where gravity is so strong that not even light can escape. They are enormous vacuum cleaners, devourers of stars, and strange substances that hide in the shadows of our universe. Could such a black hole eventually grow uncontrollably, swallowing the Earth from the inside? CERN researchers have assured the public that any black hole created would be unstable and would vanish very quickly. Regardless, the remote possibility has sparked discussions, fears, and awe at the incredible power we now possess. When protons are smashed together at nearly the speed of light, the energy created is so enormous that it twists the texture of spacetime itself. It's like dropping a heavy object onto a tautly stretched trampoline. If the object is heavy enough, it creates a deep depression that draws in anything nearby. This analogy pertains to the fundamental operation of gas pedals and particles in the field of quantum physics. In quantum theory, the laws governing our world are both strange and amazing. There is a theory suggesting that more dimensions may be concealed within our existence. If these dimensions are real, the LHC's research could create a gravitational well that produces a tiny black hole. Some incredibly well-known scientists have expressed interest in the strange movement of particles, particularly the late Stephen Hawking. In his writings, Hawking warned that the Higgs boson could become unstable at very high energy levels. Such instability could result in catastrophic vacuum decay, not only destroying the Earth but potentially obliterating the entire universe. In his book about the future of mankind, renowned English cosmologist and astronomer Sir Martin Rees also examined the possible risks of particle collider experiments, including those at CERN. His remarks were not only wise but tinged with existential dread. He predicted a worst-case scenario in which a botched experiment could result in vacuum instability. In the world of high-energy physics, the rewards are immense, but so are the risks. Every new discovery holds the potential to revolutionize our understanding of reality, but it also brings us closer to forces we may not fully comprehend or control. As CERN continues to push the boundaries of knowledge, it does so under the watchful eye of the global scientific community and an increasingly concerned public. The experiments conducted within the Large Hadron Collider are governed by strict safety protocols and rigorous peer reviews. Yet, the sheer scale of the forces involved, energies comparable to those present at the dawn of the universe, inevitably invites both awe and trepidation. Beyond black holes and vacuum decay, there are other theoretical concerns. Could the LHC accidentally create exotic forms of matter, like strangelets, that might trigger catastrophic chain reactions? Could it disturb the fabric of spacetime enough to open microscopic wormholes? Could undiscovered laws of physics lead to consequences we cannot yet predict? While these possibilities remain remote and speculative, their very existence underscores the profound responsibility that accompanies scientific advancement. To explore is human nature, but with exploration comes risk, and with risk comes the need for careful stewardship. Despite the dangers, the work at CERN has already borne extraordinary fruit. The discovery of the Higgs boson in 2012 confirmed a key piece of the standard model of particle physics and deepened our understanding of mass itself. Investigations into dark matter, supersymmetry, and the true nature of the universe's early moments continue to break new ground. The LHC is not just a machine, it is a symbol. It represents humanity's relentless desire to ask questions, to seek truths beyond the horizon of known reality, and to challenge the very limits of what is possible. It is a temple to curiosity, a monument to ingenuity, and, perhaps, a gateway to a future far stranger than we can imagine. As we stand at the edge of discovery, we must proceed with both boldness and caution. For in seeking to understand the universe, we also hold the power to change it, in ways both magnificent and terrifying. Only time will tell whether the LHC will remain a beacon of human achievement or whether it will one day be remembered as a Pandora's box, cracked open by the ambition of a species that dared to touch the stars. Possibility requires careful thought because there is absolutely a lot at stake, and there is a significant amount of room for instability. It's possible that this instability could theoretically bring about a shift in phase that would reverberate through the fabric of spacetime, leading to a disastrous event that could engulf the entire universe. In actuality, Brian Cox acknowledged the significance of this recognition. Despite widespread worries regarding the activities at the LHC, he emphasized that there are extensive safety measures in place, thorough reviews, and protocols to make sure that the operations of the LHC are carried out with the highest possible level of detail-orientedness. CERN experts have conducted simulations, analyzed the hypotheses, and adopted every precaution to guarantee the LHC's safety. Cox reassured that the energies involved are well within what the Earth naturally experiences, and the chances of creating a stable black hole are low in the cosmic scheme. Even if one were created, scientists predict that it would be so fragile and small that it would dissipate rapidly during an energy explosion, a phenomenon predicted by Stephen Hawking and known as Hawking radiation. This would be a brief moment of massive wonder, a fleeting glimpse into the void, and then it would be gone. Some have even gone so far as to speculate that the LHC's experiments could open a portal to another dimension or universe. Despite this, most scientists largely reject such notions. Theoretically, however, it has piqued the interest of numerous people and has emerged as a topic of fear and fascination with the question of what lies beyond our universe. Could we accidentally activate forces or entities that we are unable to comprehend? The concept of building a portal to hell has even been sensationalized in the media, provoking doubt. But how did this idea come to be, and what does it signify for scientific research? The idea of additional dimensions in string theory physics is not new. There may be more dimensions to space than the traditional three. In accordance with a prominent contender for a single theory of everything, these additional dimensions may be compressed or obscured from our view, but in certain extreme cases, they may be accessible or made visible. Imagine the LHC as a cosmic key that unlocks doors that have been locked since the beginning of written history. When two protons collide at energies never before attained on Earth, they may theoretically produce ripples or waves that probe the hidden dimensions. If these dimensions exist, the LHC may even reveal them. But before we get caught up in wild speculation, it's important to realize that despite the LHC's obvious power, there is no concrete evidence that it will open a door to a different world, let alone to hell itself. Nevertheless, the fascination with the unknown, combined with the enigma of quantum physics, ensures that such concepts will continue to captivate the public imagination. So, should we be concerned about the LHC and its possible dangers? In reality, the scientists at CERN are well aware of the risks involved and have taken all necessary precautions to ensure the safety of their experiments. They continue to monitor and assess their work with the utmost diligence. It's easy to get carried away by dramatic headlines and fears of a worldwide catastrophe, but the potential advantages of the study, the improvements in our knowledge of the cosmos, the discovery of new particles, and the investigation of dark matter, are simply remarkable. It's a window into the very core of the cosmos as well as a display of human brilliance. Nevertheless, like any significant scientific advance, it has risks. We should approach it with a healthy dose of amazement, courtesy, and prudence. The frontier of scientific investigation, where theoretical physics and experimental reality converge, is symbolized by the massive Hadron Collider, which continues to awe and terrify some individuals. Despite extensive safety precautions and careful calculations, the machine's sheer size and the energy it generates are astounding, and each new experiment opens up new scientific vistas. Although the majority of researchers are confident regarding the security of LHC experiments, there are obvious security holes nevertheless. Its true potential to answer fundamental questions about the universe, like where mass came from and the nature of dark matter, is unmatched. The LHC pushes the frontiers of human knowledge and our ability to regulate the natural world, as particle collisions replicate circumstances unseen since the Big Bang. But what if something else happens? What if abnormalities emerge that cast doubt on our comprehension of physics and the rules of the universe? Such experiments prompt existential concerns about the possible results of changing the fundamental components of the universe. Despite this, the LHC has produced major contributions to particle physics, including the discovery of the Higgs Boson, which has improved our comprehension of the Standard Model and created avenues for future discoveries that might influence our technological future. The search for knowledge continues to be one of humanity's most ambitious endeavors, despite the risks. There are always dangers associated with scientific discovery, and the LHC is no exception. For decades, tests have delved into areas of physics where intuition is no longer relevant. Physicists have attempted to comprehend nature's underlying forces, electromagnetism, gravity, the strong nuclear force, and the weak nuclear force, all of which are essential to the evolution of matter. These forces, though familiar in name, operate at levels of complexity and interaction that challenge even the most sophisticated models. The LHC's experiments aim not only to observe known phenomena but also to discover unknown interactions, undiscovered particles, and perhaps entirely new physics that could revolutionize our understanding of existence. One of the key pursuits at the LHC is the exploration of dark matter, the elusive substance that is believed to make up a significant portion of the universe's mass yet remains invisible and undetectable through traditional means. Unlocking the mysteries of dark matter could provide answers to some of the most profound questions in cosmology, such as the fate of the universe and the true nature of gravity. Another goal is to test the limits of the Standard Model, the current best framework for understanding subatomic particles and their interactions. While successful, the Standard Model is known to be incomplete. It does not fully explain phenomena like gravity or dark energy. By pushing particle collisions to unprecedented energies, scientists hope to find cracks in the Standard Model structure, revealing deeper truths that could unify all fundamental forces under one elegant theory. Still, with great ambition comes unavoidable unease. Any experiment that seeks to recreate conditions just moments after the Big Bang inevitably stirs philosophical, ethical, and existential debates. What responsibilities do we bear when manipulating forces that govern the birth of the cosmos? Could unintended consequences arise, however unlikely they may seem? These questions, while important, are weighed against the rigorous safety assessments performed by leading physicists and the stringent protocols that govern every operation at CERN. Decades of accumulated knowledge, peer-reviewed studies, and global cooperation form a bulwark against recklessness. Moreover, history teaches us that fear often accompanies scientific progress. The splitting of the atom, the mapping of the human genome, and the first ventures into space all sparked public anxiety. Yet each of these milestones also ushered in extraordinary advancements that transformed human life for the better. Thus, the Large Hadron Collider stands as a symbol, not merely of human technical achievement, but of humanity's eternal struggle between curiosity and caution, between wonder and fear. It is a monument to our willingness to ask the hardest questions and to seek answers, even when the outcomes are uncertain. As research at the LHC continues, it serves as a powerful reminder that the pursuit of knowledge is, by its very nature, a venture into the unknown. Yet it is through this venture that we expand the horizons of what is possible, illuminate the hidden structures of reality, and come closer to understanding our place in the vast, mysterious cosmos.